All right, welcome to this explainer. Today, we're jumping straight into what is honestly one of the most fascinating evolutionary stories in the entire Web3 space. We're talking about Polygon. But listen, we aren't just going to look at it as a piece of technology. We're looking at it as a literal masterclass in pragmatism. Our core theme today is how a really practical, ship-first, decentralized-later approach allowed what was supposed to be a temporary band-aid to organically grow into this massive, multi-billion-dollar global infrastructure ecosystem.
I absolutely love this quote. Purists called it a sidechain. Users called it salvation. That tension right there was at the absolute heart of Polygon's origin story. Back in the early days, you had blockchain researchers and purists endlessly debating perfect architectural theory, sharding, and really complex scaling models on Twitter and in these dense white papers. But everyday users, they didn't care about consensus theory. They just wanted a network that actually worked. And major mainstream brands like Starbucks, Nike, and Reddit completely agreed. They chose Polygon's practicality over the purist theory to onboard tens of millions of regular people.
Okay, let's dive into this. To really understand Polygon, you have to understand the glaring pain point of 2021. During the absolute height of the crypto boom, Ethereum was essentially unusable for normal people. A simple token swap meant facing fees like this: $80 just to swap. Minting a digital collectible could run you $200 in network gas fees. The network was literally choking on its own success. And right next door, Polygon was offering this: a single penny. That stark, unbelievable contrast in cost is the entire reason Polygon exploded. They offered a temporary stopgap solution, and the market absolutely devoured it because users were desperately seeking a lifeline away from Ethereum's crushing fees. It wasn't about having the most perfectly elegant tech, it was just about surviving the gas wars. So, here is our roadmap for today's explainer. First, the $80 problem. Next, the stopgap that stayed, followed by the ZK pivot, building the blockchain internet, and finally, the multi-chain reality. Let's get into it. Section 1. The $80 problem. Shipping while others debated. Let's trace exactly how the founding team, a group of incredibly driven engineers, by the way, tackled Ethereum's scaling bottlenecks head-on when the network needed it most. Take a look at this timeline, because timing is everything here. Polygon actually started off as Matic in 2017, placing a massive bet on a tech called Plasma. But Plasma was incredibly difficult to build and, well, ultimately failed. So in 2020, they pivoted. They shipped a simpler proof-of-stake sidechain just as a temporary stopgap. And then 2021 hit. Ethereum gas hit $80, and because Polygon's stopgap was fully EVM compatible, meaning it spoke Ethereum's native coding language right out of the box, major decentralized apps like Avi could literally just copy and paste their code directly over. Almost overnight, this temporary chain exploded to $10 billion in total value locked. Just an absolutely massive influx of user funds deposited onto the network.
Moving on to Section 2, the stopgap that stayed. Let's look at how Polygon PoS actually works.
So what started as a band-aid is actually still the network most people refer to when they say Polygon. But what is Polygon proof of stake actually? Actually, scratch that. It's better to ask what it's classified as. It's a sidechain. It runs parallel to Ethereum. It uses a two-layer architecture where Bor produces these extremely fast 2-second blocks, and Heimdall posts checkpoints back to Ethereum. But here's the absolute crucial thing you need to take away from this. It relies on just 100 active validators. It doesn't inherit the full, robust, decentralized security of the Ethereum mainnet. And this brilliantly illustrates the core trade-off. On one side, you have a true rollup, which posts all of its transaction data directly to Ethereum Layer 1, meaning anyone can reconstruct the state, and it's incredibly secure. On the other side, you've got Polygon PoS. It only posts checkpoints, and more importantly, it relies on a 5 of 8 multi-signature bridge to secure the billions of dollars falling back and forth. Think about that. If 5 of those 8 key holders are compromised, the bridge could theoretically be drained. So it's a highly practical system for sure, but one built on very distinct trust assumptions. Which brings us to Section 3, the ZK pivot. Zero knowledge to the rescue. Now, the Polygon team completely knew the sidechain had these security trade-offs, so they took the immense wealth they'd generated during the boom and initiated a multi-billion-dollar quest for true decentralization. Critics and analytic sites like L2Beat kept asking this valid question: wait, is Polygon actually an L2? Objectively, looking at the PoS chain, the answer was no. But rather than getting super defensive about it, Polygon used this exact critique to drive one of the most aggressive and frankly expensive technological evolutions we've ever seen in crypto. They made a staggering $1 billion bet on zero-knowledge technology. While everyone else was still arguing in Twitter threads, Polygon went on a massive shopping spree, acquiring elite ZK engineering teams like Hermes, Mir, and Miden. They spent years grinding away to build multiple solutions. They built the zkEVM for perfect Ethereum equivalence, they built the Miden VM for advanced parallel processing using the Rust coding language, and they shipped Validiums tailored specifically for ultra-low-cost gaming. They didn't just pick one flavor of scaling. They basically said, we're building all of them. The absolute crown jewel of this billion-dollar bet is the zkEVM rollup. This layer 2 executes your transactions off-chain, but then posts a highly complex mathematical validity proof, a zk Stark, directly back to Ethereum. So why does this matter to you? Because it finally gave users the ultimate dream scenario. You get transaction fees around 15 cents, and you get the ironclad, mathematically guaranteed security of the Ethereum mainnet with absolutely no clunky 7-day waiting periods to withdraw your funds. It is finally a true layer 2. All right, moving to section 4, building the blockchain internet. Let's talk about the CDK and the AggLayer. See, after successfully building multiple scaling solutions, Polygon realized the future wasn't just about one single dominant chain. It was about connecting thousands of them. If you use crypto today, you know fragmentation is a total nightmare. You might have your Ethereum over on Arbitrum, your USDC stuck on Base, and an NFT chilling on Polygon PoS. Your liquidity is literally split across 50 different isolated islands. Having to constantly bridge assets between them is slow, it's expensive, and frankly, it is highly risky. It just makes the overall user experience terrible. Let's see how this builds into Polygon's ultimate fix for that, the AggLayer. Think of it kind of like this. Say you're on chain A and you want to send some USDC over to chain B. The AggLayer intercepts that intent. It creates an instant cryptographic zero-knowledge proof that the asset was burned on chain A, which then allows chain B to instantly mint it. There are no waiting days, no clunky third-party bridges waiting to get hacked. It mathematically unifies liquidity across completely separate, independent networks. It's a real game changer. But to get networks onto that AggLayer, developers need a ridiculously easy way to build them in the first place. Enter the Polygon CDK, or Chain Development Kit. Honestly, think of this as WordPress for Layer 2 blockchains. A developer comes in, they pick their execution environment, they pick where they want to store their data, and they pick their proving mechanism. Major players like Immutable, for example, are using this incredibly modular, standardized kit to spin up their own custom, fully functional blockchains in a matter of days instead of years. And of course, to tie this whole massive infrastructure together, the core token had to evolve alongside it. So in 2023, the famous Matic token migrated over to POL. The main idea here is that POL is designed as a hyper-productive token. It doesn't just sit there paying for gas on one single chain. It actually accrues value by providing gas, staking, and sequencing services across all of the hundreds of new CDK chains popping up in the wider ecosystem. Finally, section 5. The multi-chain reality. Let's look at Polygon versus the world. So the crucial point to take away is this. When you take a step back and impartially look at the current landscape, there really is no single winner that takes everything. It's like a giant puzzle. If you're holding millions of dollars, you absolutely use the high-security vault of Ethereum L1. If you want deep, decentralized finance liquidity, Arbitrum is the current king. If you're looking for consumer apps seamlessly tied to an exchange, Base is fantastic. But if you're doing lots of retail transactions or playing high-speed Web3 games where literally every single cent matters, Polygon PoS at 1 penny per transaction is still incredibly hard to beat. They all serve a very specialized purpose in this multi-chain reality. Which brings us to our final provocative thought. Polygon started off by simply refusing to wait around for Ethereum to solve its own problems. They shipped a centralized stopgap because it is exactly what users desperately needed right then and there. And then they brilliantly used that massive momentum to build true decentralized zero-knowledge infrastructure. So the big question we're left with is this. Will this pragmatic, ship-first philosophy, combined with the power of the AggLayer, ultimately crown Polygon as the invisible, foundational plumbing of the decentralized internet, the TCP/IP of Web3? It is going to be a fascinating evolution to watch. Thank you so much for joining me for this explainer. I really hope it brought some clarity to the wildly complex world of Polygon.